The XDX design creation environment gives the user all the capability needed to quickly capture and validate their design intent with an intuitive and highly productive design cockpit. Seamless integration with analysis and verification tools provides a fully functional design and analysis solution. Build a pre-layout virtual prototype before committing to PCB design, and perform what-if analysis of critical signals, including the effects of the intended board stack-up. A focus on ease of use ensures that new and casual users are up and running quickly and efficiently. So let's take a quick look at how to create a virtual prototype from the design cockpit. The LineSim link enables you to export a net into the Hyperlink's LineSim high-speed analysis environment. Here I show how easy it is to select a net, in this case data bus 0, and enable the complete schematic export for the net, including all interconnections for pre-layout signal integrity analysis. I can switch to the Schematic Topology tab to review the drivers and the receivers for this electrical net. Notice that U13 is set as a driver, and U15 and U26 are both receivers. LineSim will open with a free-form transmission line schematic editor environment, enabling what-if analysis. Notice how the transmission line model for data bus 0 is automatically generated and loaded for simulation, using the IBIS models already assigned during design creation. Here I show how easy it is to assign a missing model, or reassign a different model, in this case to the Motorola DSP driver. To do this, I use the Assign Models dialog to select from the libraries list, then select from the devices list in order to choose the desired package and output buffer model for the virtual prototype. As you can see from the LineSim schematic, all of the models are now assigned. I am now ready to run the interactive simulation in the digital oscilloscope. When the digital oscilloscope window opens, I'll select a rising edge signal for the simulation. Notice after I start the simulation how different colours are automatically assigned to the probes for the driver and the two unterminated receivers for clarity. To measure the positive overshoot on the lower receiver, the designer can either manually select the top and bottom of the overshoot of the waveform to view the span of the voltage overshoot, or use the LineSim built-in function to automatically measure it. In this case it is 749 mV. To fix the signal integrity overshoot problems, some terminations needed to be added to the receivers. I can easily add an RC terminator to the schematic by simple drag and drop of the resistor as shown, so that it touches the left blue dot at the transmission line output. Rather than using trial and error or manually deriving the R and C values myself, I can automatically calculate and assign values to both terminators by making use of the powerful terminator wizard. I'll choose a 5% tolerance from the drop-down list, and by a single click the values are calculated and automatically assigned to both terminators. I'll now rerun the same simulation with RC termination and the values assigned. You will notice that the overshoot is reduced by about 50%. Is now only 361.5 mV. I can continue to refine the values if necessary, and then easily store the simulated results for downstream design reviews or for documentation purposes. For design exploration purposes, you can select, review and change the board characteristics for the simulation and analysis of this virtual prototype, directly from within the StackUp editor. You have now seen how the engineering cockpit allows the designer to create a virtual prototype of the PCB design for signal integrity analysis and also validate your board characteristics, which are both key elements in your design toolkit to be the first to market with today's advanced electronics designs.